Okay, so today is our only day of 6.2, which is going to be the dot product of vectors. And so with this lesson's actually a lot shorter. We technically only have one formula and then some properties. We might have two formulas. But so let's go ahead and get into 6.2 and see where we go. So we will not be doing these last two. Okay, we're really just going to be focusing in on the dot product. And so with that, let's go ahead and get our dot product formula. And so now the dot product has two names. It could be either referred to as the dot product or the inner product. That's going to end up depending on which book and which professor you have as to which one they'll use. But so with that, what we'll do is I'll take my first components and we'll multiply them together. And I'll take my second components and add them together. Here we're going to get a number, which is a scalar, which means it's not a matrix, it's not a vector, it's like every other number you're used to. And so that's one of the nice things about the dot product, is it goes from being a vector into just being a scalar value. So with this one, what I'm going to do is we'll go in and we'll first pull out my first components. So I'm going to have 4 times negative, that looks like a 7, negative 1, and then we will add it to my second components with my 3 and my negative 2. So I'll have 3 times negative 2. So from here, 4 times negative 1 is negative 4, and then I'll have minus 6. So this one's dot product is just 10. Notice as soon as I started doing the dot product, the angled vector signs went away, they're gone, we moved on. Okay. So with that, we have a few properties of vectors using our dot product. So with the dot product, it will not matter which order you do them in. And so that's what the first one is. It's saying that it's commutative. Okay. The second one will be a little bit easier and faster for you if you remember that the dot product of u is its magnitude squared. And so, for example, so this is for a scalar vector, not scalar, unit vector. And so, not a unit vector, it's what is the same one. So if I have 2 and 3 dotted with 2, 3. Okay. So with that one, the 2, 3, so that's going to give me 4 plus 9, which is 13. And 2, 3 is a common one that we used a little bit the last couple days. And so the magnitude of 2, 3 would have been the square root of 2 squared plus 3 squared, which was the square root of 13. And so you can see that if I just squared it, it also gives it to me. And so we like it when it's the same vector dotted with itself. Any vector dotted with a 0 vector is going to be 0. And then if you have a commutative setup, distributive, so if I have u dotted with a sum, it's just going to distribute the dot product to both pieces, whether it's in the front or it's in the back. Okay. And so remember, c is a constant. And so if I have a constant times u, a constant times the dot product, you're only going to multiply that constant once. So either you can multiply it by u, you can multiply it by v, or you could do your dot product and then deal with the constant afterwards. So there's not a wrong way. Just don't give it to both vectors at the same time. And you'll have a few examples of going through some of these properties in your homework, and that'll make it easy peasy to move on with. So let's talk about the angle between two vectors, which is the second formula. I was wrong, there were 2. And then after that, we're good to go. And so the angle between two vectors, we will use it to go through and find them. And so with that, let's go find the angle between, you weren't supposed to see that yet. Let's go find the angle between u, which is my negative 2, 3, and my vector negative 4, negative 1. Okay, so from the picture you can see that it's less than 90 degrees, but let's go and actually go and compute it using that formula. So let's go ahead and I'm pulling up some notebook paper so I can write a little straighter. And so my two vectors, the first one was -2, 3, and the second one was -4, -1. Okay, so just in case you did not write down the formula, my formula is the cosine of my theta equals the dot product between u and v over each one's magnitude. And they're going to be multiplied together. Okay, so let's go find some of these pieces and then we'll come back and fill it in. So with that, my magnitude of u is going to be the square root of -2 squared plus 3 squared. This is the one we've done a lot, so this one is the square root of 13 because we've done it a few times. And then the magnitude of v is going to be the square root of -4 squared plus -1 squared, which will be the square root of 16 plus 1, which is the square root of 17. And last but not least, my dot product between -2, 3 dotted with -4, -1 is going to equal -2 times -4 plus 3 times -1. So that's 8 minus 3, which is going to be 5. Okay, so going back to fill in, I will have 5 over the square root of 13 times the square root of 17 equals the cosine of theta. So to find theta, we would take the inverse cosine of both sides. Okay, so if you're jumping to type it into your calculator right now, which is okay, just be careful because we need to make sure that we type it in correctly. Both of these two parts need to end up in my denominator. So I would go and say 5 in my calculator. If you wanted to type it all at once, it would be 5 divided by the square root of 13, close that parentheses that it opens, divided by the square root of 17, close that parentheses, and then close one big one for the inverse cosine. And so by doing so, it's going to give me my angle. And so I don't have my calculator out with me right now, so we're going to go ahead and go to the solution key. And so I end up being about 70 degrees when I go in and get that value from my calculator. So that's how we do it from our calculators, which makes it a lot easier to work with. And we talked about how that was less than 90 degrees, and that 70 is less than 90, so my answer made sense with what I did. So now the solution up above shows all the steps at once. You don't have to do it all at once. It makes it easier not to go break it up into pieces like we did together. And so with that, that's the end of today's lesson. So today's lesson was much shorter than yesterday, and so your homework is 6.2 online. It might say day 1 beside it because I couldn't. It might not. I can't remember. It should be the only 6.2 one that's there. And this one is due on, I think it's is it the 30th? That's Monday? Yep, the 30th at 3 p.m. I'm here to FaceTime or Zoom or catch up with y'all for whatever y'all need. Let me help. I'm here to do so. I miss you guys. Bye.